for your knowledge, you don't have to write it down, and I'm probably not going to drive all of them unless you really want to see. But we're doing cosine double angle formulas today. And so 2 times an angle just means the same thing as a plus a, right? And look at your flip chart, your cosine sum formulas. It says cosine of the first, cosine of the second, minus sine of the first, sine of the second. And so that turns into cosine squared a minus sine squared a. So that's where the cosine formula comes from. And we can derive sine and tangent much the same ways. Cosine is a little bit different because we have several different variations. And in just a second, I'll put all of them up here on one slide if you want to copy them down then. But if we use this, we can take a couple different variations. We know cosine squared is 1 minus sine squared. And so if you did that, that's 1 minus 2 sine squared a. Or you could say that sine squared is 1 minus cosine squared. And if you did that, the cosines would get added together, so it's 2 cosine squared a minus 1. So our cosine double angle is actually 3 different options. Sine and tangent just have a single one. So the sine and tangent formulas can be derived the same way. But this is what you want to write down under your double angle identities. Cosine has 3 options, and we'll pick which option to use just based off the information given in the problem. And sine and tangent just have a single formula. We're just going to practice using these. So this tells us if sine of theta is 2/5, cosine theta is less than 0. I want to find sine of 2 theta, cosine of 2 theta, tangent of 2 theta. So you'll notice the difference. This is for theta. I want to know 2 theta. So I cannot just take it times 2. It's on my angle. So we can use our identities. We have to have a little more information. So this is going to go back a little bit to some of our beginning stuff. If I know sine is 2/5, we could set up a triangle. If sine's positive, we know it's got to be either quadrant 1 or 2. But if cosine is negative, then theta was in quadrant 2. So sine is opposite over hypotenuse. Kind of going back to our first chapter here, drawing our triangles. Can you find that missing side? We know a squared plus b squared equals c squared. Because when we add square root, we would do plus or minus. Because it's going backwards, that side is negative. Radical 20. So sine 2 theta, if I look at my formula sheet, it's 2 sine theta cosine theta. Sine, you could either use this or your triangle opposite over hypotenuse, is 2/5. Cosine, we had to have our triangle to tell. Adjacent over hypotenuse would be negative radical 21 over 5. So we get negative 4 radical 21 over 20. 3 different formula choices. It does not matter a bit which one you choose. Since I've already set up my triangle, there's really no one formula that's easier than the other. If I were just trying to use the information that I was originally given, you know, if I had sine, I might have picked the formula that involves sine, just because then I wouldn't have had to do the whole triangle. But we needed it for the other information anyway. So you can pick any of the 3 for cosine. I'll just go with the 1 minus 2 sine squared theta. So sine was 2/5 squared. Square that, we get 4/25. Times 2 is 8/25. 1 minus 8/25 is 17/25. Is that one okay? Tangent to theta, we also really have options. We have the formula for tangent to theta that we could use. Or, since we already found both sine and cosine, you could just do sine 2 theta over cosine 2 theta. So, do you want to divide the 2 answers we already got, or do you want to do the whole tangent formula? Divide them, that would be easier, I think. So, sine of 2 theta from part A, made 4 radical 21/25. Cosine 2 theta from part B, 17/25. We flip and multiply. Those 25 drop, and we just get -4 radical 21/17. What questions do you guys have on that? That's okay. So just like the last few days, there's really only a handful of types of problems that I'm doing. I have A, B's, and C's, so we can do as many examples of each type do we need. This is the first type. Do we need another problem like this? We're iffy. Let's just find, since we're iffy, let's just do one of them. Let's find cosine 2 theta. Alright, so to find cosine 2 theta, you have 3 different formula choices. You can use any of the 3 choices. But what I know is cosine of theta. So if I want the choice that would require the least work, I would pick the one that only asks for cosine in it. If you picked any of the others, you would just have to set up your triangle to start with. So we could do 2 cosine squared theta minus 1. So we know cosine, radical 3/5 squared minus 1. Radical 3 squared is 3, 5 squared is 25, minus 1. Of course, if you're getting confused on this part, you can use a calculator. We get -19/25. that okay? Let's look at this one. All right, I want all 6 trig functions of theta. So I flipped. The last one we were finding 2 theta. This time we're finding theta. But I have some information. I'm telling you that cosine of 2 theta is 3/4. So let's look at our formulas for cosine 2 theta. We have 3. We could pick any one of those to start with, except I wouldn't recommend the first one because I don't want to have to solve for cosine and sine at the same time. I would prefer one of these two because then I could just solve for one thing. All right, so what if I just did the 2 cosine squared minus 1? So that's the identity. Plug in what we know. Cosine 2 theta is 3/4. And now what we're doing is solving an equation. So if I add my 1 over, and we would have to divide by 2. All right, how do you get rid of a square? Square root. When we add a square root, we need plus or minus. But I can decide the plus or minus from this. I told you that the angle was between 180 and 270. 180 and 270, that's quadrant 3. And quadrant 3 is cosine positive or negative. Negative. I do the square root of 7. 8 would break into 2, radical 2. So if we get the radical off the bottom, we get negative radical 14 over 2 times 2 is 4. Now, I asked for all 6. So we have options now. I kind of did this really as to review some of our older stuff, so we're not forgetting things. Your homework, I don't think any of the questions ask for all 6 trig functions. If you have cosine, what else can you easily get? Secant is just the reciprocal. So that would be negative 4 radical 14 over 14, which reduces to negative 2 radical 14 over 7. To get the others, we could do another identity, or we could just draw a triangle. We know that we're in quadrant 3. Cosine's adjacent, so my adjacent side is my negative radical 14. Hypotenuse is 4. So you could find your missing side. Squared is 2. In the third quadrant, would this be a positive or a negative? You're going down, so it'd be a negative. So we get a negative radical 2. And so then you could get all the other trig functions just from that picture. Sine is opposite over hypotenuse, so negative radical 2 over 4. cosecant, you flip it. Get the radical 2 off the bottom. Tangent, opposite over adjacent. Since they're both under a radical, we could reduce. That's 1 over the square root of 7. Or radical 7 over 7. And then cotangent is just the reciprocal, so radical 7. Now, I think on the homework there's only 2 questions that ask you to find more than one thing, and I think they just ask for sine and cosine. But I figured I would take the opportunity to review this since we haven't done it in a little bit. Once you have one angle, then you can always set up a triangle to get all of them. All right. Is that okay? Other things that we might have with here, proofs, they haven't gone away, so we're still going to have them. So let's try a proof. All right. We pick a side to box it. Any thoughts? Okay. When I look at this, that's a difference of squares. So we could factor that into cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta. What's cosine squared plus sine squared? What's cosine squared minus sine squared? Cosine squared minus sine squared is cosine 2a formula, so that is the cosine 2 theta. Multiply, we just get cosine 2 theta. So proofs, still working the same. Pick a side, you work. If you get stuck, you know you can stop, go work the other side and try to get to the same point. Is that one okay? Good. That sounds painful.
It hurts when I don't focus.
Really? Okay. Last type of problem. Let's do. Let's just try simplifying some of these. If I said 2 cosine squared of 5x minus 1, and I'm just asking you to simplify this as much as you can. You're looking at your formulas. Does this remind you of a formula? and that is equal to, so this is cosine of 2 times our angle, which is 5x, and 2 times 5x is 10x. So this is just cosine of 10x. Just trying to get us to recognize our formula there. When I look at this one, it is very similar to the sine 2a formula. The only difference is, what is it missing? It doesn't have the 2. So think about the formula. If you didn't want the 2, you would divide it over, right? So this would be equal to sine of 2a, so 2 times 165, divided by 2. Is 231 off my unit circle? No, so we would just leave our answer like that. That's as far as we're going to go. One more of these. Which one does this look like? And it does match perfectly, so I don't have to do anything special. So 2 times 22 and a half, be 45. And what is the tangent of 45?